All right, in our first lesson, we focused on case one, central angle, vertex is at the center point, and the central angle is equal to the arc. All right, let's look at some warm-up problems that use central angles. So I want you to pause the video, give these a try, and then unpause the video when you're ready to go over them. All right, so NL is a diameter. So we know these three pieces put together make up 180 degrees. All right, so if we subtract 70 and 80 out of 180, we should be left with 30 degrees. That's a central angle, so JK is also 30 degrees. All right, the next thing they want us to find is NM, right? So arc NM, that's this one right here. Right? We can see that we have another diameter, MK. So when you take a look at that, we can see that this 80-degree angle is vertical with this 80-degree angle, which means NM must also be 80. All right, LM is next. All right, if you look at that, see how those two pieces together form a semicircle? That means LM must be 100 degrees. KNM, start at K, go towards N, stop at M. Well, that is a semicircle. So that's also 180 degrees. NK, that's going to be 70 plus 30, so that's 100 degrees. And last but not least, LJM. That's the entire circle except for this 100 degrees, so that will be 260. All right, so those were all central angles, case one, what we focused on in our first lesson. Today we're going to look at case two. That's when the vertex is on the circle. All right, this is called an inscribed angle. When the vertex is on the circle, the angle is equal to the arc divided by 2. All right, so we can either have an angle that looks like this, right? Where it's formed by two chords or two secants. And then we could have, that color won't do. We could have one being a secant and one being a tangent. Either way, what they have in common is that the vertex of the angle is on the circle. When that is the case, the angle is equal to the arc divided by 2, or you can say 2 times the angle equals the arc. All right, so let's take a look at this one, right? We've got the angle, and we need the arc, right? So if I call my arc X and I plug into that formula I just showed you, that says 80 equals X over 2. So multiplying both sides by 2, 80 times 2 gives us 160, right, for X, our arc. Remember, the arc is going to be twice as big as the angle. All right, let's take a look at what we have here. X represents what kind of angle, right? It's got its vertex at the center point. X is a central angle. So remember, central angles are going to be the same as their arcs. So X should be 120. But now, if we go look at Y, all right, Y is not a central angle. Y has its vertex on the circumference of the circle. So Y, the angle, is equal to its arc divided by 2. So Y is equal to 60 degrees. All right, so if you have a central angle and an inscribed angle intercepting the same arc, remember the angles won't be the same. They have different relationships with that arc. All right, let's take a look at these two examples. They tell us the measure of arc JK is 80 degrees. And then for angle JMK, that's this one, all right, we can use the expression 2x minus 4. All right, first we want to think about what kind of angle this is. It's an inscribed angle, right? This represents the angle, and 80 represents the arc, right? So we know the angle, 2x minus 4, is equal to the arc, 80 divided by 2, right? So that means 2x minus 4 equals 40. So 2x equals 44. And that means our x value is 22. Right, so that was the first one. Let's take a look at number 2. This time they tell us the measure of angle MKS, right? So MKS is 56, and they want us to find the measure of arc MS. Remember we said we could do 2 times the angle equals the arc. So that means 2 times 56 will equal arc MS. That gives us 112. All right, so arc MS is 112. Remember, we can do 2 times the angle to get the arc, or we can do angle equals arc. Just depending on what information we have, they are the same relationship. All right, let's take a look at this one. We're looking to find the measure of angle dog. That would be this one. And the measure of angle dig, this one. All right. And if I take a look at angle dog, right, highlight it, I can see that it is intercepting this 72-degree arc. All right, so if I want to get the angle, I need to take my arc. Angle equals 72, arc divided by 2. So that's going to leave me with 36 degrees for angle dog. Now when I go look at angle dig, highlight that, turns out it is intercepting the same arc, right? So this angle would also be 72 divided by 2, so we get 36 again, right? This brings up a special property. If 2 inscribed angles, they have to both be inscribed, intercept the same arc, then they're going to be congruent. All right, so if you ever see 2 inscribed angles intercepting the same arc, those angles are going to be the same. So that really helps us on problems that look like example 3, right? Because all I have for my angles, measure of angle 3 is 5x, right? That's this one. And the measure of angle 4 is 2x plus 9. Right, well, we don't have any number values or degree values for our angles. But when we take a look, we can see that each of these angles intercepts arc QD. So that last property told us we know they must be equal, right? That means we can take those 2 expressions and set them equal to each other. From there, we can solve it out and get our x value of 3. All right, now we're going to take a look at some inscribed polygons. If all the vertices of a polygon touch the edge of the circle, meaning all the vertices are on the circumference of the circle, then the polygon is inscribed. So we see that each separate vertex of the polygon is its own inscribed angle, right? So sometimes we use special properties with these. Other times we just break them down into their separate inscribed angles. All right? One of those special properties is with the quadrilateral. If you have a quadrilateral inscribed inside your circle, then the opposite angles are always going to be supplementary. Right? We know that means they equal 180. So if you take a look at angle A and angle C, right? If you add them together, they would equal 180. They're opposite of each other. If you take a look at angle B and angle D, right? If you add those two together, they would equal 180. All right, so let's take a look at number 4. We want to look for the opposite angles. I see that Z is opposite of 85. So to find Z, I could say Z plus 85 equals 180, right? And solving that, that would give me that Z is 95. Right. Then I have another pair of opposite angles. I have Y and 110. Since they're opposite of each other, it would be Y plus 110 equals 180. Solving that, I would get that Y equals 70. All right, if a right triangle is inscribed in a circle, then the hypotenuse will be the diameter of the circle. Right? There's no other way to draw a right triangle inscribed inside of a circle. If a side length of a triangle inscribed in your circle is the diameter, all right, this property works in the opposite direction. If I know that the diameter is a side length, that's enough to prove to us that it's a right triangle, right? Let's take a look at how we might use that. In circle K, GH is a diameter, right? And the measure of angle G and H is 4x minus 14. Find the value of x. All right. Well, since we know that this is a diameter, right? Even without that property, we could figure out that this was a right triangle. And let's see how. Since this is a diameter, I know that all of this is a semicircle. So this must be 180 degrees. Then when I take a look at angle G and H, right, we see it intercepts that semicircle. So 180 divided by 2 gives us 90 degrees right here. Right? So it is a right triangle, and we can say 4x minus 14 equals 90. So that gives us 4x equals 104, right? Dividing both sides by 4, we get x equals 26, right? So if you have the diameter as a side length of a triangle in your circle, you know it's going to be a right triangle. All right, we just have a couple more examples to look at with our inscribed. All right, still looking at case 2, and now looking at this second way that it can look. All right, so we looked at a lot that look like this. Right? Now we're going to look at a couple that look more like that second one. All right? The important thing here, right, is that the vertex of this angle is on the circle. Yes, one of the rays is a tangent and one of the rays is a secant, so it looks different, but it follows the same rule. They're telling us that the arc is 84 degrees, and they're asking us to find the measure of angle 1. All right? Well, we know that the angle, when it's inscribed, is equal to the arc divided by 2. So for this one, the measure of angle 1 is equal to 84 divided by 2. So the measure of angle 1 is 42. All right, let's take a look at example 2 here. All right, again, it looks different because we've got a secant line and a tangent line as our rays. All right, but this one's also different because they didn't give us this arc that we need to help us figure out the angle. But they did give us this arc, right? What I want you to notice is that 202 and our unknown arc, right? If you put them together, that's the whole circle. So if I do 360 minus 202, right? That tells me my missing arc. 360 divided by 202, or divided minus, that'll give me 158 for x. Now that's not my final answer. That's this arc right here. So 158. Then we know that the angle that we're looking for is equal to its arc divided by 2. So in this case, the measure of angle 1 is equal to 158 divided by 2. So the measure of angle 1 is 79. And we are good to go. All right, you have an activity to do after this on your inscribed angles with their vertex on the circle.